Have you ever wondered if our entire galaxy is moving towards something? Something so massive, so mysterious, that even scientists cannot see it directly? Imagine looking into the night sky and realizing that the Milky Way, the Andromeda Galaxy, and hundreds of thousands of other galaxies are all drifting in the same direction. Not because of the expansion of the universe, but because something unimaginably powerful is pulling them. This invisible cosmic giant is known as the Great Attractor. Today, we're diving into one of the greatest mysteries in modern astronomy, where gravity bends the fate of entire galaxies and challenges everything we know about the universe. At first glance, the universe appears to be expanding evenly in every direction. This discovery, first made by Edwin Hubble in the 1920s, led scientists to believe that galaxies were simply moving away from each other due to the expansion of space itself. But in the 1970s, astronomers noticed something strange. The Milky Way wasn't just moving with the expansion of the universe, it had an additional motion. Careful measurements revealed that our galaxy is racing through space at approximately 600 kilometers per second, or over 2 million kilometers per hour, toward a specific region in the southern sky. Even more astonishing, thousands of nearby galaxies were moving in the same direction. This unusual motion became known as a peculiar velocity, meaning a movement beyond the normal expansion of the universe. Something enormous had to be pulling all of them. As astronomers investigated further, they discovered that it wasn't only the Milky Way. Our entire local group, which contains more than 80 galaxies, including Andromeda and the Triangulum Galaxy, was heading toward the same destination. Even larger structures, such as the Virgo cluster and many neighboring galaxy clusters, appeared to share this cosmic journey. Eventually, scientists realized that over 100,000 galaxies across hundreds of millions of light years were all being influenced by the same mysterious gravitational force. The destination was eventually named the Great Attractor. But where exactly is it? The Great Attractor lies roughly 150 to 250 million light years away in the direction of the constellations Norma and Triangulum Australe. Unfortunately, observing this region is incredibly difficult because it sits behind the dense disk of our own Milky Way. This area of the sky is called the Zone of Avoidance. Thick clouds of stars, dust, and gas block visible light, hiding whatever lies beyond. Imagine trying to observe an entire city while standing inside a thick fog. You know something is there, but you simply can't see it clearly. To overcome this obstacle, astronomers turn to radio telescopes, infrared observatories, and X-ray satellites, which can penetrate the cosmic dust. These observations revealed enormous concentrations of galaxies hidden behind the Milky Way. One of the most important discoveries was the Norma cluster, an incredibly massive collection containing hundreds of galaxies. Scientists estimate that this cluster alone has the mass of about 1,000 trillion suns. Yet even that enormous amount of matter still isn't enough to explain the powerful gravitational pull affecting such a vast region of space. This raised an even bigger question. Could there be something even larger hiding beyond the Norma cluster? In 2014, astronomers studying galaxy motions identified an enormous supercluster they named Laniakea, a Hawaiian word meaning immense heaven. Laniakea stretches across more than 500 million light years and contains around 100,000 galaxies, including our own Milky Way. Instead of floating randomly through space, every galaxy inside Laniakea appears to flow toward the same gravitational center, the Great Attractor. In other words, our galaxy is just one tiny passenger in an unimaginably large cosmic river. But the mystery doesn't end there. Beyond the Great Attractor lies something even more astonishing. The Shapley Supercluster, one of the most massive structures ever discovered in the nearby universe. Some astronomers believe that the combined gravity of the Great Attractor and the Shapley Supercluster may be responsible for the motion of galaxies across this enormous region. Others argue that the Great Attractor itself is simply part of an even larger web of galaxy clusters connected across billions of light years. In the universe, gravity doesn't always come from a single object. Instead, countless massive structures work together like invisible hands, shaping the movement of galaxies over cosmic time. Now imagine the scale of these forces. The Earth orbits the Sun because of gravity. The Sun orbits the center of the Milky Way because of gravity. The Milky Way itself is moving toward the Great Attractor because of gravity. And perhaps even the Great Attractor is moving under the influence of structures larger than itself. Every object in the universe is part of an endless gravitational chain stretching across unimaginable distances. Compared to these cosmic giants, our entire solar system is smaller than a grain of sand in an ocean. One common misconception is that the Great Attractor will eventually swallow the Milky Way. Fortunately, that's not how gravity works on these enormous scales. The universe is still expanding, and in the far future, the effects of dark energy will dominate cosmic expansion. Although our galaxy continues moving toward the Great Attractor today, it is highly unlikely that everything will collapse into one giant object. Instead, the balance between gravity and cosmic expansion will determine the long-term fate of galaxies. The Great Attractor also reminds us of another invisible mystery: dark matter. Scientists estimate that ordinary matter, including stars, planets, and gas, makes up only about 5% of the universe. Around 27% is believed to be dark matter, an invisible substance that interacts through gravity but cannot be seen directly. Many astronomers suspect that huge amounts of dark matter surround galaxy clusters near the Great Attractor, strengthening their gravitational pull. Although we cannot observe dark matter with our eyes, its influence can be measured through the motion of galaxies, making it one of the strongest pieces of evidence that this mysterious substance truly exists. Even after decades of research, the Great Attractor remains one of astronomy's greatest unsolved puzzles. New observatories, more powerful space telescopes, and next-generation radio arrays continue mapping the hidden universe beyond the Milky Way. Every new discovery reveals more galaxies, more clusters, and even larger cosmic structures, suggesting that the universe may be far more interconnected than we ever imagined. Perhaps the most fascinating part of this story is what it says about humanity. We often think of ourselves as standing still on Earth, but in reality, we're traveling through space at incredible speeds. The Earth spins around its axis, orbits the Sun circles the Milky Way moves within the local group flows through the Laniakea Supercluster, and the entire supercluster is drifting toward the Great Attractor. Every second of our lives, we are passengers on a cosmic journey across hundreds of millions of light years, without feeling a thing. The Great Attractor is more than just a mysterious region of space. It is a reminder that the universe is filled with invisible forces, hidden structures, and unanswered questions. Every discovery reveals an even greater mystery waiting beyond the horizon. Perhaps someday, future generations will finally uncover what truly lies behind the Zone of Avoidance. Until then, the Great Attractor remains one of the universe's most powerful and fascinating secrets, silently pulling entire galaxies through the darkness of space. If you enjoyed this journey into the mysteries of the cosmos, don't forget to like the video, subscribe to the channel, and join us for more incredible stories from the universe. Because out there, the greatest mysteries are still waiting to be discovered.